So it looks like there has been some interest in my coverage of the models presented in Too Tall Toby's CAD versus CAD tournament. Here I am today with another video covering match 1 of the quarterfinals, the Elite 8, Ex Machina versus Imants, a Libre versus Onshape. So here we go. Let's take a look at model number 1.
In 3, 2, 1, go. What is the mass of this part in XXX grams? What is the mass of this part in XXX grams?
So this model is kind of tricky because it's a tier 5 model, but essentially, if you haven't seen my previous video about angles and tangency in plasticity, check it out, because essentially this video deals with a little bit of tricky angles, a little bit of tangency, and we're going to be using a lot of the very similar tricks from that video in this model. So let's just look at the drawing and let's get started with the plan of attack. So here, what I'm going to do is, looking at this drawing, a lot of the dimensions are based off of this center slot shape. So the first thing we're going to do is build this slot shape. And then the next thing, I guess the trickiest part of this model is positioning this cylindrical piece on the top right corner, because we're not really given the height of this cylinder or this circle. We are given the width, which is 38 millimeters relative from the center of the slot, but we're not really given the height. So really what this slot is defined by is this 135 millimeter line, and then also this 135 degree line, as well as this 23 degree line. The circle needs to be tangent to both of these lines, and that's kind of how we define the position, the height of this circle. So in order to get this 135 degree line, it's connected to this tombstone shape. So then tracing backwards, after we build this slot, we need to build this tombstone shape. Then we can build this line. Then we can define the circle, and then finish off the profile with the other line. So with that in mind, let's get started in plasticity. So first things first, let's check the units of measurement. I'm going to press Control comma on my Windows PC or Command comma on your Mac. Go to grids and units, make sure it's millimeters, and we're good to go. So I'm going to select this solid, click X to clear it, and we're going to switch over to the front view. Here, to define the slot, I'm going to use the rectangle tool, specifically the center rectangle, so I can get everything aligned on the origin. So using the rectangle tool, click on the origin, drag outwards, press C, and here we're given that this is a 20 millimeters slot. That is a through hole. So that means that the width of this rectangle must be 20. So I'm going to press tab, enter in 20. Now the height we're not given, but we are given the height of the kind of outer slot. And we're also given that the thickness or the offset between the inner and outer is 8, which means that if you think of the slot as having like 2 sides, or an offset of having 2 sides, which means that 115, we need to minus the width of the 2 sides to get the height of the inner slot. So that would be 115 minus 16. So 115 minus 16, that'll be the height of the inner slot. Press enter twice to confirm. I'm going to press / to zoom all the way in. Now I'm going to press B for fillet, D for distance. And because this is a 20 millimeter slot, which means that if you think of it in relative to a circle, that means that the diameter of the circle is 20. We're dealing with radius here, so we just divide that by 2. So for the fillet, the distance we're going to enter is 10, and that gives us our rounded shape. And again, we've already established that the outer shape has an 8 millimeter offset. So with this curve selected, press O for offset, D for distance, enter in 8, and now we have that slot shape. And once again, the next part we need to do is define that tombstone shape, and we're given that it relative to the bottom of this outer slot, there's a 123 millimeter height. So using the center circle tool, I'm going to click on the bottom of this slot, drag open, press V to switch from vertical to horizontal, making sure it's horizontal now with the X axis, press tab, enter in 20, because it's given on this diagram that the radius of that outer piece is 10. So you multiply that by 2. The diameter is 20. Press enter twice to confirm. Press G for move, Z for the Z axis, and enter in 123. Now our circle is in position. Now I'm going to rotate the camera a little bit. Actually, I'm just going to switch over to the top view. Here we're given that the tombstone shape is actually defined by a line that is 13 millimeters relative to the center. So here, using the line tool relative to the center, drag horizontally, press tab, enter in 13, enter twice to confirm. And then with this line select, I'm going to press Alt X to mirror, press Y in the Y axis and to mirror it across. And now using the line tool again, I'm just going to finish connecting in and finish defining that tombstone shape. Using the trim tool, I'm going to trim away that extra arc. Now we have that tombstone shape defined. Now we need to define that 135 degree line. So using the line tool again, we're making sure that we're starting off from the midpoint of this edge over here. And then I'm gonna switch over to the front view. And if you watch my previous video, we're trying to define a line where the degree is relative to horizontal. So we just enter it as is. So we just need to go press tab, enter 135, and that is the line. Left click, then right click to confirm. Now we need to define that circle. And here we're given that there's a 38 millimeter offset from the center of the slot. So we're going to draw in a reference line. So along the Z axis, I'm going to just draw in a line and press G for move, X to lock into the X axis and move it by 38 millimeters. So we know that the center of our circle must be on this line. Now, the other thing is that this circle must be tangent to this 135 millimeter line. So what that means is that we need to draw another line that is perpendicular to this 135 millimeter line that represents the radius of that circle. So the diameter of the circle is 33. So that means that the length of this line must be 33 divided by 2. And here, this pink line, this pink edge represents the line that's parallel to the line that I'm drawing off of. And again, this is binormal. Here, if you just want to lock it in to this parallel axis, there is a command on the bottom that says binormal. So you can, if I just press B right now, it doesn't matter where, if I just press B right now, it doesn't matter where I move my mouse, it's locked into this parallel axis. So again, I guess I need to enter this again. The radius is 33 divided by 2. So the diameter divided by 2 is the radius. Left click, then right click to confirm. In order to really get the center of the circle, we know that it must lie on this vertical line. It also must lie on the end of this perpendicular line, which means that we just need to move this perpendicular line in place because 38 millimeters, this is stationary. That's already given to us in the diagram. So in order to just move this, which means that we need to move this line in the direction that is parallel to the 135 degree line. In order to do that, we'll select this curve, press G for move, F for freestyle, and then click on the end of this edge over here. That's going to be our pivot. And here on the bottom, we're given this command again, B for binormal. That's what we want. We're going to press B. So now it locks it into this parallel direction. Now I just need to move it until we get that tooltip, binormal, curve, and intersection. Now we know that that's the intersection between these two lines is where our center of the circle needs to live. So now it's switching over to the center circle tool. Now I can just click on this intersection. Just draw a line outwards like this. And then notice how, again, here it is, 33 millimeters. That's the diameter of our circle. Left click, then right click to confirm. And I can delete these two reference lines. Next thing is going to be this 23 degree line that needs to be tangent to this circle. So we're just using the line tool. I'm just going to draw any arbitrary line. Now this is 23 degrees relative to vertical, which means when we press tab, we don't just enter in 23, we enter in 90 minus 23. And that is the line. I'm going to left click, then right click to confirm. Press G to move, F for freestyle, select this tip or this end of this line over here, and then now hover over this circle until we get that tangent tooltip. That's going to be, let's see, I missed it. Oh my goodness. Zoom in a little bit, make it easier. There we go. Tangent, come on. Tangent, there we go. Tangent. Now notice that this line is a little bit too long. I do want to trim away some of the stuff, but if I just trim right over here, it's going to leave like this tiny bit inside, and it's going to be a little bit annoying to trim away the proper piece. So in order to do this, I'm just going to scale this line down a little bit. With this line selected, I'm going to press S for scale, F for freestyle, select that end of that line, and then T for tangent because I still want it to be along this line. And then now I just need to drag it onto this tip over here and then just move it to where I want it to move. And then left click, then right click to confirm. Next thing we need to do is define this 12 millimeter, I guess this width over here. So we can just use the offset tool using this with this line selected, press O for offset, D for distance, 12, and then enter twice to confirm. Now notice that this line is actually not long enough. This line needs to touch the edge of the outer slot. So with this line selected, just press S for scale, S for uniform, and then just drag it a little bit longer, make it a little bit longer. Left click, then right click to confirm. Now we got that face that we can extrude from now. And then lastly, I think the last piece is we just need using the line tool. I'm gonna make sure to select the middle of this tombstone again. Left click, switching back to the front view, just drag downwards until it intersects with that outer slot. Left click, right click to confirm. Now we have that face to extrude from. And that's pretty much it. That's all of the profile that we need to start extruding. So switching over to face selection, I can select this slot, select these two faces to represent that cylindrical piece. Both of these are 25 millimeters in width. So I'm gonna press D for distance, 25. I'm gonna divide this by 2, so then I can do a midpoint extrusion. Press tab to do that midpoint. And now we have these 25mm width extrusions. Left click, then right click to confirm. From the tombstone shape, I'm just gonna press on the tombstone. One thing to note, what I'm gonna do is I'm just gonna drag and eyeball it. It just needs to extrude such that it's fully inside of this slot shape. And the most helpful thing for that would be to turn on this X-ray mode if it's not enabled. So on this top right corner, turn on X-ray mode. That way, if I press D for distance now, I can see through it, and I can see that this line, this corner over here crosses over into the insides of the slot. That way I know that the shape is good. So left click, then right click to confirm. Here we're given that this fin or this rib piece is 8mm. So I'm going to press D for distance. I'm going to enter in 4, then press tab to do a midpoint extrusion to get a total of 8. Enter twice to confirm. And then lastly, this part over here, this has the same width as the tombstone. So I'm just press D for distance. I'm gonna hold down Control and just snap it to the end of this edge of the tombstone, then tab, and then right click to confirm. So now I'm going to press A to select all of the solids, Q for Boolean, Q for Union, right click to confirm. And now the last thing we need to do is define those holes. I'm going to select the existing curves because we don't need them anymore. Press X to delete them. Using the center circle tool, I'm going to start from over here. And the hole over here is 16mm. So I'm going to put in 16. Press T for cut. Select the solid. Right click to confirm. And with that cutout solid, that cylinder, that's the result of the cut. Press X to delete it. Now going over to the tombstone shape, starting from the center, using the center circle tool, enter in 14. And then also we need a through hole of 8. So enter in 8. Now going back to face selection, we'll select that first face. Press D for distance, enter in 4. It's going in the wrong direction, so I'm gonna press minus. I'm gonna left click, then press W for difference, right click to confirm. Similarly, I'm gonna select this face. I'm just gonna press D for distance, drag, make sure that's through the first part of the solid. Left click, W for difference, left click on the solid, right click to confirm. And that's pretty much our part. Now to calculate the mass, I'm gonna have the solid selected. I'm gonna open up the calculator. And here it says that the volume is 81,171.27 millimeters cubed. And from Tool Tall Toby, the density is 7,800 kilograms per meters cubed. So I'm gonna multiply this by 0.0078. And that gives us our mass of...
And Imants coming in with an answer, 63.137. And that is correct. So well done. Well done. Congratulations to Imants.
That's of 633.13 grams, which is the answer for model number 1. Moving on to model number 2, let's take a look now.
3, 2, 1, go. Oh, this is a good one. Wow. What is the mass of this part in 0.xx pounds, plus or minus 0.01 pounds? And this part is dimensioned in inches. It's ABS, and it is a tier 4 part. It's called a hollow football.
So this model was pretty interesting. I never thought that I'd ever be modeling a football. That's kind of cool. There is one part that was challenging in Plasticity, which is this 0.625 spherical dimension, which I'll show you kind of the challenges that I went through to get that working. But the good news is that Phosphor, our Plasticity expert, did release a video of him modeling this football, but using the beta version of Plasticity. And in the beta version, there are improvements to the existing tools that make this a lot easier to build. But I'm still running the stable version. I'm running, as of right now, 1.4.18. And those tools have a little bit of limitation, but let me show you how I kind of worked around them anyways to get it working. So jumping into Plasticity with the new scene, we got to make sure that we're in inches. We're in inches right now in this scene, so we're good. Like always, clear the solid, and I'm going to switch over to the front view. Here we're given that the width of this football is 11.5 inches. So using the line tool, I'm just draw right on this x-axis, press tab, enter in 11.5. Enter twice to confirm, and then we're going to center this on the origin. So I'm going to press G for move, F for freestyle, then right click twice, and now it's centered. The next thing to do is to define this apex of this arc that we want. So again, the strategy is that we're going to define an arc, and then we're going to revolve it to get that football shape. So in order to get this apex, we do have this height of the football given to us, which is 6.5 inches. We're dealing with half. So from the origin, I'm just going to draw a line up from the z-axis, on the z-axis. Press tab, enter in 6.5, divide that by 2, and that will represent the apex of our football. Initially, when I thought, hey, we need to get this 0.625 spherical dimension in, I love working with circles. Some people use arcs. For some reason, it just makes a lot more sense to me to just deal with circles and then trim away parts that I don't need. So instinctively, I know it's a little bit slower, but instinctively I thought, hey, if I just use a 2-point circle, I'm just gonna do that now. If I just use a 2-point circle and I just draw a circle on both sides of this line, press tab, enter in 0.625, mirror it onto the other side. Now I can just use a tangent circle where as long as the first curve and the second curve is along this outside of these circles and the tip of the circle touches this apex over here, that is the arc that I need to create that football. But unfortunately, that doesn't work. So I'm going to switch over to the tangent circle tool to demonstrate why. So with the tangent circle tool, I'm going to select this first curve, second curve over here. And now notice how like it likes to use the inside edge. And no matter how I move, sometimes I can get it. Like if I move the mouse over, like sometimes it uses the inside of the circle and the outside of the circle, but I can never get it to just be on the outsides of the circle. So again, not to say that it's a bug, but I guess it's the tool right now doesn't have that much control over it. So that's the issue. But why is this happening? So I'm thinking, okay, this is because we're giving it too much freedom to choose where it needs to be tangent to. So the solution to this is to limit the areas that it can be tangent to. So like I said, we don't want these inside edges and we don't ever want it to be like tangent to the bottom of the circle. So let's just not give it that opportunity. So if I just trim away this stuff over here, and again, we said that we don't want it to be on the inside of the circle. So if I just use this to draw a line, just kind of limit it and just trim away that inside. Okay. I'm just going to trim away this. Now, if I create a tangent circle, using a tangent circle and say, just make it so it's tangent to this curve, I'm limiting to where that circle can be defined. So now with this curve selected, so like this little bit over here, Alt X, mirrored on the X axis so I get it on the other side. Now use the tangent circle again, select this first curve, second curve. Now see we've limited where that circle can be tangent to, and this is what we want. So now I can select that apex, which is defined by the end of this line, and that's our arc. So I can now just trim away all the bits that we don't need. We also don't need this reference line anymore, and that's that. There's also this 0.125 inch wall. You can use the shell command. For some reason, I tend to just like using offsets. So with the edge selection tool, I'm going to select these three curves. I'm going to press J to join them. Now I can press O for offset, D for distance, and I'm going to enter in minus 0.125. And that'll give us our shell. So now we have this face that we can select. Okay, so with this face selected, now I'm going to take this face. Now I'm going to use the revolve tool on this bottom right. We're going to revolve around this X axis, and that gives us our football shape. The last thing are the stitches, and that's actually the easy part. In Plasticity, there is this imprint command. Here, we're given the perspective, like a top-down perspective of what the stitches look like. We just need to actually define that from the top-down view. And then using the imprint command, which is basically a projection command, it'll project those edges onto the curve shape, and that's actually what we want. So from that, it creates faces that we can offset from. Easy peasy. Yeah, from the top down, we can actually just hide the football for now. From the top down, we just need to build these stitches. And the easiest way to do that is just a bunch of rectangles. First, I'm going to define that horizontal rectangle. So from the origin, press C to switch to a center rectangle. And we're given that the width is 6.25 inches. So press tab, enter in 6.25. And the height is 0.5 inch. So I'm entering 0.5. Now we just need to draw these vertical rectangles. So again, using the rectangle tool, I'm just going to define one first. Here it says that the height is, or the width is 0.25. And the height is 1.625. And then we can see that there's the spacing that's given is that from the inside, I'm going to I'll call it inside, but like these inside edges, it is 0.8 inch spacing between them. But if we're looking at the origin, we're dealing with half. So from the origin, the leftmost edge is 0.4 inches. Let's align this to the origin along the left edge and then move it by 0.4 inches first. So with this curve selected, press G for move, V to change to pivot, and I'm going to select the pivot to be this anywhere the middle of this left edge. Now I can just hold down Control and drag it such that it's on the origin, and that's in the correct spot. Now I'm going to press G again to move it, X to lock into the X axis, then move it by 0.4 inches. And now the first part is in the correct spot. The next thing I'm going to do is with this rectangle select, I'm going to press Shift D to duplicate. We need to move it by 0.8, but it's 0.8 relative to the inside edges, right? So if I just move it 0.8 now, that's not enough. We need to move it by 0.8 plus half of the width of this current rectangle. So again, we're locked in on the X axis. We're going to enter in 0.8 plus, and then the width of this is 0.25. So 0.25 divide by 2 because we only need half of it because we're moving it relative to the center right now, and that'll give us the correct position of the second part. And then we got to do one more time for the third one. So again, Shift D, duplicate this rectangle, X lock in the X-axis, enter in 0.8 plus 0.25 divided by 2, and that gives us the position of the third one. And then the rest is just mirrored. So I'm going to select these 3 rectangles, Alt X to mirror. We're going to mirror it along the X-axis, and now we have the stitches in place. Now, here's a trick I actually learned from Phosphor, watching his video. Because initially when I did this, so if I unhide the football, and let's just select all these rectangles, I'm gonna press G to move, Z to lock in the Z axis, I'm gonna move it up here. So it's clear to think like if we just project downwards, that's what the imprint does. It imprints these faces onto the solid over here. So if I have all of these, if I just select all of these rectangles, press Shift I for imprint, and then I'll select this football. Notice how if I did not trim away these, if you don't trim away these extra bits, then if we just want to offset these faces, we have to go and click each one, which is kind of annoying. So I found out that that's pretty annoying. So when I did the first run through, I went and actually trimmed all the insides. But trimming on the insides is not super annoying. Like you can just go in and, you know, like let's hide this using the trim tool. I can just select all these at once and then just go in. It's still kind of annoying because it's like I have to be precise with the mouse, but that's what I did. But what I learned from Phosphor, very interesting. What you can actually do is just select all of these curves, Shift D to duplicate them, and that just gives you the profile without all these extra edges. So this new curve. So now I can delete these other curves, and that just saves so much time. That was amazing. Okay, plasticity, amazing. So now I didn't have to go in and delete them manually. Select all this, select this curve, Shift I to imprint it onto the football. Now you can just select, well, there's still this middle line that's dividing them. By now it's just selecting 2 faces instead of, you know, a million faces. And then press D for distance, enter in that offset of 0.15, and that's pretty much it. That's the football. So very cool thing I learned from Phosphor watching his video. You know, little ways to speed up your modeling. Now to calculate the mass, so how I do it is I switch it back to millimeters because then everything is relative to the metric system first, and then I convert it back to pounds. I'm press Control, comma, go to grid, select millimeters. So now if I click over here, it gives me the volume in millimeters, and then I have the conversion memorized. So 383,933.19 millimeters cubed. The density is ABS 1020 kilograms per meters cubed. So I'm going to multiply by 0.00102, and that'll give me things in grams. And then I memorize the conversion. So I just need to divide this number by 453.592, and that gives me the mass in pounds.
And the mod's coming in with an answer, 0.861. And that is correct. And that is going to give Imants the win, and it's going to allow him to move on in the tournament. Well done.
And that gives us 0.863 pounds. And that is the solution for this football model. So hopefully all of this helps. Congratulations to Imants for advancing into the semifinals. Good try, Ex Machina. I love the Libre. It was a good attempt. I love seeing a Libre represented. But yeah, if you like this video, give it a thumbs up. But as always, thanks for watching. Bye now.